We are going to start with the volumetric analysis. Volumetric analysis is the quantitative analysis of compounds. What we did is only qualitative analysis, that is salt analysis. We have checked the ions present in the compound, that is qualitative analysis. Qualitatively we have seen what are the ions present in the compound. Now next is we are going to find out the quantity of the substance present. It is quantitative analysis. For that we are doing, or we are titrating known concentration of a solution against the unknown concentration and finding out the concentration of an ion in a particular solution. So what we are going to do here is the volumetric analysis. Volumetric analysis using the pipette and burette, the apparatus we are using, that I will come later. Now there are two experiments we included in the volumetric analysis in this year, that is estimation of potassium permanganate solution using a standard solution of more salt and estimation of potassium permanganate solution using a standard solution of oxalic acid. So we will start first with the estimation of potassium permanganate solution using standard more salt solution. Now, last year we have studied oxidation reduction reaction, that is redox reaction, in which one substance is oxidized and the other is reduced. See, the volumetric analysis we are going to do, this is a type of reduction or redox titration, that is one oxidizing agent and one reducing agent. Here the oxidizing agent we use is acidified potassium permanganate and the reducing agent we use is more salt. Now what is more salt? More salt is FeSO4, NH4 twice SO4, NH4 twice SO4, 6H2O. This is more salt. The formula of more salt is FeSO4, NH4 twice SO4, 6H2O, and this is a double salt. A double salt is a salt which when dissolved in water, it will split into constituent ions. So you will get Fe2 plus ions, sulfate ions, ammonium ions, etc. So all these ions will be there in aqueous solution. You can estimate any one. So here we are using the substance which are going to be oxidized is Fe2 plus ions in more salt. It is oxidized to Fe3 plus ion. It is oxidized to Fe3 plus ion plus electron. This is the oxidation half reaction taking place. Fe2 plus will be oxidized to Fe3 plus. Now, so since it is oxidized, it is a good reducing agent. So this will reduce potassium permanganate, that is MnO4 minus ion, to Mn2 plus. Mn2 plus ion. So permanganate ion is reduced to Mn2 plus ion. So permanganate is the oxidizing agent. It is oxidizing in presence of an acid or in acidic medium. So Fe2 plus is oxidized to Fe3 plus and MnO4 minus is reduced to Mn2 plus. Now we will have to balance these half reactions. MnO4 minus to Mn2 plus. Here there are 4 oxygen atoms. To balance that, we will add here 4 H2O. Here there are 8 hydrogen. Here we will add to balance that. Since it is acidic medium, you add 8H plus. This all we have studied last year. So it is 8H plus. Now how many electrons? Here the oxidation state of manganese is X plus into minus 2 is oxidation state of oxygen, 4 oxygen. So the total oxidation state is minus 1. So X is equal to minus 1 plus 8, it is plus 7. So oxidation state of manganese here, it is plus 7. It is reduced to plus 2. So how many electrons we will have to add? We will have to add 5 electrons. So this is the reduction half reaction. Now oxidation half reaction. Fe2 plus is oxidized to Fe3 plus. Here there are 5 electrons. We will have to multiply, make this also 5 electrons. So multiply this reaction with the 5. So it is 5 Fe2 plus 5 gives 5 Fe3 plus. plus 5 electrons. Now when you add this, what will you get? The total reaction is 5 Fe2 plus MnO4 minus plus 8H plus. Now 5 electrons here and 5 electrons will cancel. You will get 5 Fe2 plus, sorry, Fe3 plus Mn2 plus 4H2. This is the total reaction. Now here Fe2 plus is oxidized to Fe3 plus and MnO4 minus is reduced to Mn2 plus. So this is a redox titration. A redox reaction is taking place, oxidation and reduction. So we are going to find out the amount of potassium permanganate or permanganate ion in the solution using a standard Fe2 plus solution. That is more salt solution. That is what we are going to estimate. So what is a standard solution? A standard solution is a solution whose concentration is known to us. So we would have to prepare a particular concentration solution of more salt, and using that we will estimate the potassium permanganate or the permanganate ion present in the solution. That is what we are going to do. So that is the quantitative estimation we are going to do, and this type of titration is a redox titration. So now how we are going to do it, that is one. So aim of the experiment is to estimate the permanganate solution or the permanganate ion present in the solution using standard more salt solution. So that is the first one. Aim is to estimate the given KMnO4 solution using standard more salt solution. So we are going to prepare a more salt solution, and this more salt solution we are going to prepare is m by 20. M by 20 means 1 by 20 molar, that is 0.05 molar potassium permanganate, more salt solution we are going to prepare, and using that more salt solution we are going to estimate potassium permanganate solution. Theory is what we have written now, that is this equation MnO4 minus plus 8H plus 5 electrons will give you Mn2 plus, that is the reduction half reaction, plus 4H2O, then Fe2 plus 5 Fe2 plus gives 5 Fe3 plus 5 electron. This is the theory behind it, that is the quantitative estimation is based on this reaction. MnO4 minus plus 8H plus 5 Fe2 plus will give you Mn2 plus 5 Fe3 plus 4H2. This is what we are going to do. Now the equation what we are going to find out is, here it is M1 V1 is equal to M2 V2. M1 V1 sorry by N1 is equal to M2 V2 by N2. M1 is the molarity of the first solution. Solution 1 is more salt solution. So M1 is the molarity of more salt solution. Molarity of more salt solution that you are finding out. You are preparing the solution. You know the M1. Now V1 is the volume of more salt solution. You are going to take a particular volume of more salt solution. Then N1 is its coefficient in the equation. Coefficient of more salt, that is Fe2 plus. Now what is M2? M2 is that of KMnO4. M2 is equal to molarity of KMnO4, which we don't know, KMnO4. Then volume V2, after titration we will get the volume of KMnO4. Then N2 is its coefficient, that also we know here from the balanced equation. So you know M1, you know molarity. We are going to prepare the solution. M1 we know, V1, volume of more salt solution we are going to prepare or take a particular volume. So V1 also we know. N1 is the coefficient is 5. Isn't it? In the balance equation, the coefficient of more salt is 5. So N1 also you know. M2 is the molarity of KMnO4 solution that we will have to calculate. Then V2, volume, we are going to get a reading. From the reading, we can find out the volume of potassium permanganate. N2 is its coefficient. Coefficient here it is 1. So N2 is equal to 1. So all the quantities we know except M2 that we can find out. Okay, so this is the theory behind it. Now, how to prepare the procedure? Procedure is after this procedure. Now, in procedure, what we will have to do first, we will have to prepare a standard solution of more salt solution. So, preparation of standard more salt solution. More salt solution. How much? M by 20 more salt solution. For that, you will have to take a particular weight. You will have to first calculate the weight required to prepare M by 20 more salt solution. How to calculate? What is molarity? Molarity is equal to number of moles of solute. Number of moles of solute divided by volume of solution. Volume of solution into 1000. Right? We are going to prepare only 100 ml solution. So volume of solution is 100 ml. We are going to prepare 0.05 molar. M by 20 is 0.05. Is equal to number of moles. How will you find out? Given mass by molar mass. Molar mass. Is it by volume of the solution is 100 ml. We are going to prepare 100 ml into 1000. Now what is the molar mass of more salt? Molar mass of more salt is 392. You will have to add all the atomic masses FeSO4, NH4, twice SO4, twice SO4, 6H2O. So for this, the 392 is the molar mass. Okay. So instead of molar mass, we can divide by 392 into 100 into 1000 is equal to 0.05. That means it is 392 into 0.05 by 10. That is equal to 1.96, right? 1.96 gram. So if you take 1.96 gram of more salt, dissolve it in 100 ml solution, you will get M by 20 more salt solution. Now using this M by 20 more salt solution, we are going to estimate the potassium permanganate solution. That is the theory behind it. Now we are going to do the procedure. Now the apparatus we are going to use for this titration. This is a watch glass. We will have to use a watch glass. Now this is the funnel. Using that you are going to transfer the contents to the standard flask. Now this is the standard flask. It is also called a volumetric flask. This is a 100 ml standard flask. You see here there is a round mark here. You can see the mark here. Now when you prepare the solution, the lower meniscus of the solution must touch here. Then it will be exactly 100 ml. So when you prepare the solution, the lower meniscus of this level must touch this mark. Then it is exactly 100 ml. Okay. So this is the standard flask. Now you are going to do the titration in this. It is called a titration flask or conical flask. We are going to take the solution, that is more salt solution here. Now, how to take the more salt solution? If you are preparing the solution in the standard flask, this is called a pipette. This is pipette. You are going to pipette out. Again here also there is a mark here. If the lower meniscus of the solution touches this mark, then it is exactly 20 ml. We are going to pipette out the 20 ml. So if when the lower meniscus touches here, it will be exactly 20 ml. Now how to fill this or how to take the solution using pipette that I will show. Fill it like this here. You have to suck in. See, then close it with the forefinger. Should not use thumb. Always we have a tendency to use the thumb, but you should not use that. Use the forefinger and slowly release the forefinger and see the level will come down. Slowly it will come down. When it reaches that mark, you stop it, then it will be 100 ml. For that your hand must be very dry. Then only you can control it properly. Okay, this is how we pipette out the 20 ml. And you have to be very careful. The level should not rise above the liquid level or the solution level. If it rises, the whole solution will go to your mouth. We are acidifying the solution. So you must be very careful when you are pipette outing. Okay. So this is how we are. This is a pipette and how we are going to use it. So this is more salt solution. We will take using this one. Now the next is burette. This is a burette. This is burette stand we are going to use. Let's keep this there. This is the burette. It is a 50 ml Borosil burette. Now here the marking is from here 1, 2, 3 up to 50 here. 50. Okay. And all this filling up to here, this brim, it will be 50 ml. So you have to be careful that no air holes must be there inside. Fill it completely. Okay, so this is burette. These are the apparatus we are going to use for the titration. Okay, proceed. 0 here. What you have to do, you keep the watch glass over this pan. Then tire 1's button is here. You touch that, then it will again become 0. Then you start adding, you will have to take 1.96 gram. So you add a substance till it is 1.96. Okay. Exactly 1.96 you can take. Nine. കാണിക്കുന്നുണ്ടല്ലോ 9.5 ആണ്. So you take it, it is 1.96. Then we are going to transfer that contents to the funnel, then wash them, wash the sides of the funnel, then tip of the funnel, keep it there. Then what you have to do is you have to take sulfuric acid and add it to prevent hydrolysis. Then add some more water and dissolve completely. So then close it tightly like this. You have to step. No solution will go up. See how? Okay. So we have prepared the more salt solution. Now next what we are going to do is we are going to pipette out. See, we have added acid, so you must be very careful. So we have washed the pipette. Now what you will have to do is you will have to rinse the pipette. Now how to rinse the pipette? You take pipette after washing, remove all the water here and take a little bit, a small quantity of the more salt in the pipette. Now we are going to wash, see, by rotating it everywhere. You rotate it and then see all the places with the pipette must be washed with this more salt solution, so that we will have to remove all the water present in it. So this is rinsing. You rinse the pipette with the more salt solution. There. Now we will have to pipette out. Suck it to a higher height and slowly release it. Like this. Slowly you release the finger, then the level will come down, and when it touches that round, okay, now that lower meniscus is touching that circle or that line, then you take the conical flask and pipette it out. Okay, now this is exactly 20 ml. See, don't take enough time so that all the liquid goes down by itself. Okay, and all the liquid is down. But do one thing like this, touch the side ones. Okay, then a little bit will be remaining here. Excluding that, it will be 20 ml. This is included in that. Okay, so excluding this will be 20 ml. Exactly, this is 20 ml. Now what we will have to do is, it is acidified potassium permanganate you will have to titrate. We cannot add acid to the potassium permanganate here. So for that, what we are going to do is we add acid to the more salt solution. Now this more salt solution we will take only 20 ml we will have to add. So 1.5 test tubes of this acid we will have to, 4 normal sulfuric acid we will have to add. Nearly 1.5 test tubes of sulfuric acid we have added. So this is more salt solution, acidified more salt solution. Now ready for the blending. Now take the burette. We will have to now fill the burette with the potassium permanganate solution. Dark bottles, so that in presence of light no oxidation will take place. Usually potassium permanganate will be kept in such dark bottle. Again, like burette, we have to rinse burette also. Burette I have washed it and kept. Now how to rinse it with the potassium permanganate. Take a small quantity of potassium permanganate. must be fully filled. Okay, and the upper meniscus must touch the 0 mark here. Okay, now this is touching the 0 mark. Now we have rinsed and taken potassium permanganate in the burette. Now the question is how to titrate. How do we know that all the reaction is over? Where will we stop? See, the end point is a permanent pink color, because during the reaction permanganate ion, which is that pink color, is oxidized to Mn2 plus, which is colorless here. So what happens is the color will disappear. When this reaction is taking place, then all Fe2 plus, when it will be converted to Fe3 plus, permanganate ion will be converted to Mn2 plus. When all the Fe2 plus is reacted or it completely converted to Fe3 plus, then no MnO4 will be converted to Mn2 plus. Ella Fe2 plus Fe3 plus I MnO4 will not be converted to Mn2 plus. That means the pink color will not disappear. So you must get a pink color by the addition of one drop. That must be a permanent pink color. That is the end point, where all the Fe2 plus is converted to Fe3 plus, then correspondingly MnO4 minus is converted to Mn2 plus. Okay, so you will have to titrate till you are getting a permanent pink color. See how the reaction, how to catch the burette. You see, I am keeping it here with the left hand. You catch like this. Okay, then right hand you will have to hold the conical flask. Like this. See, all the color is disappearing. No color. Till the permanent pink color you are getting. I am taking using a white background so you can identify easily the color. In between you will have to check whether any color is there on the sides. If there is any color liquid remaining, you will have to wash it with the water and keep it down. Okay, because if any potassium permanganate color is there, that means that much volume we are reducing. So we will have to be very careful. Sides of the conical flask there should not be any pink color. So very carefully you will have to do the titration. It is a quantitative analysis. See, you got a permanent pink, very slight permanent pink color. Okay, this is the end point. Our reaction is over. Now what you have to do is take the spirit out and keep at your eye level and take the reading. It is 18.8. 18.8 is the reading. And you will have to see once more whether any color is disappearing. It must be permanent, because when suppose it takes time to oxidize, you will have to see the color is not going. So it is a permanent pink color. Our correction is, so the reading is 18.8. Okay. So what you will have to do is, like in physics you cannot take average. So you will have to repeat it again, throw this one again, pipette out 20 ml using pipette, add acid, titrate it till you are getting concordant values, means two readings, same reading simultaneously you will have to get. That means one reading, next after that consecutive reading must be the same. So with this one you can take 4 readings. With the 4 readings, 2 must be similar. Then you can start. Okay. Minimum 3 you will have to do. So this is how we do the